Do you remember this project of mine? If not, let me tell you that a big spider had a guest part in it. And if you're still not sure, let me clarify that it is the SMS alarm system I built for my friend's garage 8 years ago. Now this thing worked pretty flawlessly for around half a decade. But at some point it just stopped working for reasons unknown. The only problem now is that sadly crime rate is increasing around here, which I can definitely confirm because someone attempted to steal a moped out of my garage as well. And only thanks to my own loud alarm system they got scared off. And my friend, of course, also has treasures in his garage that he wants to protect. Which is why it is time to build a new alarm system. But this time upgraded with the newest technology, meaning a 4G LTE connection to send alarm notifications to a smartphone super quickly, a radar for human presence detection, and of course an industrial-grade siren that will scare off anyone who hears it. Let's get started! This video is sponsored by Nordic Semiconductor. Nordic provided the 4G LTE development board for this project, the NRF 9160 development kits. And for those of you who don't know Nordic, they are one of the world's leading providers of low-power wireless microcontrollers, with products, development tools and solution across Bluetooth LE, Wi-Fi, cellular, power management and more. Now first off, let me present you the game plan, which I already partly spoiled by revealing the 3 big components / features, which includes the 4G LTE boards, the radar human presence sensor and the siren. Besides those 3 things though, we also need a custom designed enclosure, think about how to power everything, and how we can control it all with a microcontroller and some complementary components. But let's start off with the big 3, and let's go from easy to a bit difficult, meaning we start with the siren. Now truth be told, my friend gave me the siren, and I have no idea where he got it from. But it appears to be quite expensive, and thus it also came with a pretty decent datasheet. To use it, all we have to do is apply plus 12 volts to one of the upper 2 terminals, and ground to one of the following 2 terminals. And there we go, pretty simple. What is noteworthy is that this siren draws very little power and you can set this dip switch in order to change the playback tone. So all in all, a great piece of hardware which will be a perfect fit for the new alarm system. Moving on to the radar human presence sensor, which looks like this, and you can get it for pretty cheap from the internet. You might recognize it because I reviewed a similar unit in a previous AliExpress hidden gem video, and back then I was very happy with its capabilities. To use it, we simply have to connect its pins to a USB to serial converter like shown here, plug this converter into a computer and open the software given by the manufacturer. And after then pressing connect and start, the 2 graphs on the right start going crazy, which indicates that this thing works correctly. But for mounting the sensor later on, I this time plan to install it inside the main enclosure, because the product description claims that it should be capable of penetrating through it. So to properly test this, I went into the future and got myself the final lid for the enclosure, onto which I can secure the radar to test it out. Now besides the serial communication the sensor comes with, which is responsible for the data transfer, we also got an out pin that pulls up to 3.3 volts when someone gets detected. That is of course way easier to use for the alarm system, and the only problem at this point was that the sensor pulled this pin high pretty much continuously, because it was not fine adjusted yet. To do that, I firstly defined the moving and motionless max RG to 2, which basically means that the sensor only triggers when someone gets detected within a range of 2 times 0.75 meter, aka 1.5 meter. Then I also set all the sensitivity levels to 60, that the measured values need to be above to trigger. And after doing quite a bit of testing with these values, it seems to work pretty well. As you can see, when I'm farther away the output stays low, but as soon as I get in range it reacts quickly, and even stays on when I'm not moving, which is the big plus point of such a radar. Only if I move away the output returns to low again, which not only means that these settings fit, but also that the sensor works flawlessly behind its lids, and thus we can finally move on to the hardest parts, aka the 4G LTE data connection. Now don't get me wrong, the old way I did things with a prepaid SIM card and a GSM 2G board did work pretty well. But of course, due to older mobile network technologies slowly shutting down, and because you have to pay a bit of money for every SMS, it is not the ideal solution anymore. So going 4G makes sense, because coverage is good and I only need to send a couple of bytes of data that will cost me pretty much nothing for a long time to come. And this NRF 9160 development board from Nordic Semiconductor should do the trick, since it supports lte-m, which is kind of like a 4G LTE network, but with a bigger range and lower data transfer rates. And according to the network coverage map given by iBasis, which actually supplies a working SIM card with the boards, I should have lte-m coverage here in Germany. So the first thing to do for me here was to see whether this network really works. And that meant creating an NRF cloud account, registering my SIM cards, adding the boards to the clouds, and ultimately installing a bit of software to update to the latest firmware, and also upload the given example GPS tracker codes. Because yes, this thing also comes with GPS. And after waiting for a few seconds after the uploads, it seems like everything works fine, because my exact GPS position with some other data got successfully published to my clouds. Lovely. So next, I dug through the Nordic Developer Academy courses to learn how to use this board. And there I found what I was looking for. And that was an MQTT example to push data to an MQTT broker. Sounds complicated, but in a nutshell, by pushing a button on the boards, we can send out data to the network, and thus MQTT broker, which we can listen to with, for example, a smartphone, and then get immediately notified when new data got published. For the broker, I went with mosquito.org, that was also used in the given example codes, and simply went with the MQTT dashboard app for my phone. And by the way, programming is done through the Visual Studio software, that simply requires an expansion that Nordic Semiconductor created for it. But anyway, after configuring the app the way it got described by the tutorial, and then uploading the fitting example code to the board, you can see that by pressing a button, we pretty much immediately get notified. Awesome! Now to make this example work with the radar, I simply had to add a transistor to a specific pin of the NRF board and connected space through resistor to the radar's outputs. This way the transistor pulls the pin low to ground when the radar detects something, which is the same thing the push button does to this pin as well. And as expected, now we get an alarm when the radar detects something. Success! Here comes the hard part though, because in order to control all the other additional hardware inputs and outputs with the NRF board, I would have to write my own codes. And let's just say that I'm not a software guy, and it would have taken me forever to go through all the given courses and learn coding for this microcontroller. So instead I went the easy route and used an additional Arduino microcontroller. I know, total overkill, but what counts for me in the end is whether my project works. And with this final hardware design, according to this schematic and the new code I created for it all, it should hopefully do that. To prove that, let's do a live test. When I flip the arm switch, the system tells me through the siren that it is now armed. And after a few seconds, I'm not allowed to stand in its detection range, because otherwise the system will notice that, send out an alarm and will turn on the siren for 3 minutes, meaning everything works fine and as planned. And in case you wondered, I powered everything with 12 volts, which got converted down to 5 volts for the microcontrollers, meaning this 12 volts 1 amp power supply should be sufficient to power everything in the garage. And with that out of the way, it was finally time to finish this project, meaning I designed a fitting enclosure for it, 3D printed that, mounted all of the components inside of it, which ultimately looked rather nice, and then secured it in my friend's garage. And after doing a bit of testing, we could also confirm that this thing works without a problem. So all in all, I personally think this project turned out awesome. And 4G and radar human presence sensors are definitely something I would recommend others to try out as well. If you enjoyed the video, then as always, don't forget to like, share, subscribe and hit the notification bell. Stay creative, and I will see you next time!